Yeah, hello sir. Can I start, sir? Yeah, hello sir. Ma'am, can I start right now?
Yes, yes, sure.
Yeah, ma'am. Yeah, ma'am. Yeah. Good evening, everyone. My name is Harish Kumar. So in today's webinar, I'm going to explain about the image processing. So first of all, I want to thank Career Dreams HR for giving this opportunity for presenting the image processing. So in this today's agenda, I'm going to explain about what is an image, what are image capturing devices, classification of images, what is meant by image processing, and also classes in image processing, and its application and conclusion. So first, when we come to what is an image, it is a two-dimensional function f of x comma y, and the amplitude of f at any pair of coordinates x comma y is called the image intensity at that point. In other words, an image can be described by a two-dimensional array clearly arranged in rows and columns. Okay, so an image is a picture that we can be created or copied in and stored in electronic form, such that see in your daily life we can see the image, and those images are stored in electronic devices, which are in mobiles, TVs, and all. So an image can be described in terms of vector graphics or raster graphics. An image stored in raster form is sometimes called a bitmap. When we clearly observe this diagram, this is a sample image of an Google map. So in this Google map, when you clearly observe this image consists of lots of pixels. So when you clearly zoom it, we can able to observe these pixels, where we can observe a white color and a pure black color and somewhat mixed with the gray color and all. So these colors we can observe when we zoom this image. So for each colors in each square boxes of this image, we have the mean values, which is 170 reflects to this box, and 238 reflects to this box, and 85 is also reflect to this box, because the value varies because of the light intensity of the image. So this is called an image. So what are the image capturing devices? So in our daily life, we can see there are lots of image capturing devices, including our phones, our TVs, and etc. So where the digital camera itself shows this image. Images are recorded digitally on a disk or the camera's memory. Take a picture, view it immediately. And the second one is digital video cameras. This shows this diagram, which record motion digitally. And the third one is webcams. So in all these cameras, the basic principle involved is where the image will be there, the visible rays falls on the image will be reflected back to this sensor. So in this sensor can be consist of an digitalizer. In this digitalizer, for color images, there consist of an RGB sensor, which means the visible rays consist of more number of colors. So in those more number of colors, so in this each pixels is going to vary the intensity of the light, because where there is high brightness, the pixel is going to light very brightly. Where the visible light intensity is low, this square box is going to have a less intensity. The combination of all the intensity of lights which we can be visible in the screens. In this is the 2D digital image. This is the basic working principle involved in image capturing devices. The third one is classification of images. So the images are classified into grayscale image and the color image. So grayscale image tells us about the intensity component in the image simply, but grayscale image tells us how much bright or how much dark is the intensity of the pixel. Usually there will be a set of discrete values for assigning the intensities, mostly from 0 to 255. 0 value indicates the pure black, and where the 255 indicates the high gray level for an 8-bit image. This is the grayscale image. And the color image. The color image is a digital image that includes color information for each pixel. The RGB color space is commonly used in computer displays. This is the basic red, green, blue color space is commonly used. But in other spaces, such as YCBCR and HSVs, and are oftenly used in other contexts. They are used in very less manner. A color image has 3 values per pixel, and they measure the intensity and chrominance of light. When we observe the Taj Mahal image, so here it shows the color image of Taj Mahal on the left side, and the right side it shows the grayscale image. In this color image of Taj Mahal, we can see a green color, white, and light blue of the sky. But in the grayscale image, we can only observe the white and gray only. This is the classification of image. But nowadays, the image mostly used is color image. And the fourth one is what is meant by image processing. Image processing is a method to perform some operations on an image in order to get an enhanced image or to extract some useful information from it. Let us consider taking a selfie through a mobile phone. If we take a selfie, so after taking the selfie of our image, the image can be converted into so many forms. We have so many options like brightening the image and also doing some editing operations and all. So those things are also a simple image processing technique that we have in our mobile phone. It is the type of signal processing in which the input is an image and output may be an image or characteristic features. So the features are used to compare with the standard values to determine the any fault or any other information required in the image. The first, in this image processing, there are the 3 main steps involved. The first one is importing the image via image acquisition tools, analyzing and manipulating the image, output in which results can be altered, image or report that is based on image analysis. This is a pure image of a this is the pure image during a medical treatment. So B, the image which we have extracted, and when it comes to the C and D, they undergoes through some analysis. This is the example of image processing. So in this image processing, there are different classes involved. The first one is image acquisition. Image acquisition means taking image as an input. A digital image is produced by one or several image sensors. So through, we have discussed before about digital cameras. So through digital cameras, we are going to capture the image, right? So those images will be taken as a input for doing the image processing. Besides, various types of light sensitive cameras include range sensors, tomographic devices, radar, ultrasonic cameras. So depending on the type of sensors, the resulting image data is an ordinary 2D image, or it may be a 3D volume or an image sequence. These pixel value typically corresponds to light intensity in one or several spectral bands, but can also be related to various physical measures such as depth, absorption, or reflectance of sonic or electromagnetic waves, which can be taken as an input in image acquisition. So in the diagram itself, we can observe carefully. This is a video camera. This is the sensor, which will be taken as an input through frame buffering, or and these are some operations are that took place, and it will be taken for acquisition image in the this is the system memory. So from video camera to the image will be saved in the system memory. So this image will be taken as an input, the first process. In the second process, there will be the image enhancement. Image enhancement is the process of adjusting digital images so that the results are more suitable for display or further image analysis. For example, you can remove noise, sharpen, or brighten an image, making it easier to identify key features. So, for image enhancement, we have to use, so there are many operations. So depending upon our requirement, we can use any one of it. So those operations are filtering with morphological operations, the first one. The second one is histogram equalization, noise removal using a Wiener filter, linear contrast adjustment, median filtering, unsharp mask filtering, contrast limited adaptive histogram equalization, decorrelation stretch. So these are the different algorithms or the different techniques that we can use for image enhancement. So let us take an example of this map. So here in the left side of the map, which is the A map, we can observe carefully, there is a lots of noise is there. So if we enhance the image by removing those noise, we can capture the details and we can able to clearly notice the details carefully. This is the first one. And the second one is this image where the tree is there. So it is not that much visible to us because of night and there is no light at there. So when we capture those images, it won't be clear for analyzing the image. So we are going to enhance the image. So after enhancing the image, the tree and also the shadow of the tree is more clear for after enhancement. This is the second process that took in the image processing. The third one is image segmentation. This is also the important process that took place in the image processing. The goal of segmentation is to simplify and or change the representation of an image into something that is more meaningful and easier to analyze. So image segmentation is typically used to locate objects and boundaries in images. More precisely, image segmentation is the process of assigning a label to every pixel in an image such that pixels with the same label share certain characteristics. Okay, when we observe the image one, there are four persons standing over there. So those four persons we are finding out through their head only. Their body we cannot able to find because their bodies got mixed up with each other. So for detecting the each person's style and the way of standing, we can use the image segmentation, which means we are going to detect the edges of the each person, so that it indicates with the white line. So those edges are detected with the help of pixels. Okay, so through pixels we are going to divide these persons, and we can able to detect them very easily, right? This is the third process. And the fourth process is feature extraction. In the feature extraction starts from the initial set of measured data and builds derived values. For example, if we take this ROM images, so I have told you before, so the image consists of each pixel, right? So the each pixel consists of some mean values depends upon their color. If it is RGB color, the value may differ, or it may be a grayscale image, the value may differ for each image. And for each pixel, the value is also differs because of the intensity, light intensity, or light, the brightness of the image. So in these feature extractions, built derived values intend to be informative and non-redundant, facilitating the subsequent learning and generalization steps, and in some cases leading to better human interpretation. Okay, feature extraction is related to dimensionary reduction. The selected features are expected to contain the relevant information from input data so that the desired task can be performed by using this reduced representation instead of the complete initial data. Okay, so these feature extracted values are going, this is the final values that we are going to analyze with the standard values, or we can use for further analysis also. I will explain you in detail during the application. And the fifth one is image data compression. So after getting the value, the image size may be large, it may have the huge size that it may should have a high storage for sending the data or for storing the data. So to reduce those storage, so we are going to compress the image. So image compression is a type of data compression applied to digital image to reduce their cost for storage or transmission. So this is the overall view of image processing. So in the image processing, first I told that the raw image is taken as an input. It may be a RGB color or it may be a grayscale. So nowadays we are use going to use the colored images only. So we won't use any black and white images, right? So this RGB colored image is going to taken as an input in image conversion. So it will be converted into grayscale, because if we convert to the grayscale, it will be easy to analyze. So after converting the grayscale, the first step is image enhancement. And image enhancement is used to remove the unwanted noise. And also we are going to use the image uh, for edge detection. Okay, image and acquisition, image enhancement, and also background extraction. So in the background extraction, after detecting the edges and also after removing the unwanted noise, the background information are going to be extracted. So after the extraction will be done, so object detection and classification is going to be done. Features will be extracted. So those features are sent into the ANN, artificial neural networks. So in the artificial neural networks, they are going to determine the patterns. Okay, so those patterns are compared with the feature which we have extracted. So after completion, object detection and segmentation, that they will get these detected objects. So this is the overall view of image processing used in ANN, artificial neural networks. And the sixth one, coming to the applications. So in applications, first I have told image sharpening and restoration application, and also in medical fields. So in medical fields, we use these image processing techniques in scanning in maternity hospitals, or ECG scanning, etc. So there we are going to use this image processing, and also in determining the retinopathy disease and other diseases which we can found out through scanning only. Okay, so this image processing is highly used in the medical field, and also the third one is a remote sensing, and the fourth one is transmission and encoding, and the fifth one is mission robot vision. So in mechanical engineering, in the mechanical department, we can say through image processing we are going to determine the path that robot should travel, or path to weld the two metals. So these are the techniques that we are going to use in the mechanical engineering field also. And during the production, inspection, the production and inspection, they are going to use these image processing techniques. And the second and the next one is color processing, and also pattern recognition. This is a very important topic, pattern recognition in AI, artificial intelligence, and ANNs, and also the video processing, and also microscopic imaging. So these are the applications that we are going to use of this image processing. The seventh one is conclusion. So I have explained a few of good introductory of image processing. So there are many more complex modification you can make to the images. So there are different operations that we can use, different techniques we can use to change the images, and we can also apply various types of filters are there during image capturing and image processing also. So those filters use mathematical algorithms to modify. Okay, so different techniques and different algorithms have different mathematical calculations. Some filters are easy to understood. There are some basic filters that are very easy to remove the noise or to determine the edges of an image. So these two techniques, we have some very easy techniques or very easy algorithms also, while other require a great deal of technical knowledge. So there are some more other filters which are very complex and also very optimized one. So those techniques or those algorithms, we should have the great deal of technical knowledge. And thank you. Yeah. So this is one of the applications of the image processing. So I have told in the image processing, the medical field has great scope for this image processing. So they're gonna use this image processing very much to determining any diseases related to eye or related to stomach and etc. So there are the three steps involved in this methodology or in the first. So I am going to explain you about the uh, retinopathy. So retinopathy is one of the cause of impairment of eye vision, which leads to damage to retina. So irregular sugar levels in the blood flow, abnormal blood flow in the retina, and hypertension causes the retinopathy. With the help of computer application and tracking and estimation of diameter of blood vessel is possible. The MATLAB software is used to track and estimate the blood vessel. In this software, the retinal image is given as an input image, and the image processing methods are carried out to determine the diameter and track the retinal blood vessel. So this technique distinguishes bifurcation focuses, which might be valuable for further post quantitative and compositional investment. So this is one of the application example of image processing. So that I am going to talk about. And the main objective is to track the center line of blood vessel and to determine the bifurcation of a blood vessel, to estimate the diameter of a blood vessel, edge detection of an image. So these are the main objectives of this application. So in this, I'm going to use the algorithm which is Gaussian algorithm. First one is parameter initialization. The second one is image acquisition. The third one is seed point selection. The fourth one is compute a 3D matrix used to generate kernel matrix, simple vessel tracking, bifurcation detection, and diameter estimation. So these are the steps that are involved in my algorithm. So visual tracking. To follow the center line of visual, we expect that the bend fluctuates easily and has an Gaussian dispersion in a solitary visual section without bifurcations. Accordingly, we expect that the EB and flow of ebb and flow of veins is a GP, Gaussian process. So this is a formula that we are going to use for determining the diameter of a vessel. I'm going to explain you. Wait for some time. Yeah, this is the retinal image. This is the eye image of an human. This is the human eye image. Let us take. So this human eye image is taken as an input in a MATLAB. So we are going to plot the graph depending upon the mean values of the image. Okay, so these these blue dots represent the mean value, extreme values of a eye diameter. So this eye vessel, this red line represent the eye vessel, and these blue dots represent the extreme values of this eye retina, eye vessel. Okay, so this graph represents the center point index and the difference between M1 and M2. So this I have told before that M1 and M2 determines the extreme values of blood vessel. So the extreme values are plotted in this graph. These dots represent the extreme values of this blood vessel. Okay, so by using this blood vessel tracking, so we are going to determine the eye vessel diameter of a human. uh, so this eye vessel diameter is going to compare with the uh, retinopathy disease eye. So when we compare those two values, if the value is somewhat nearly equal to this value, we can say the human eye is suffering with retinopathy disease. If those values are not equal, so then we can conclude that the human is not suffering with the retinopathy disease. This is a basic example for human eye. This is a basic example for image processing. So that's all. Thank you, sir, for giving this opportunity. For giving this opportunity to represent my webinar.